Hello and welcome to my channel. I am BeardedDev, bringing you another SQL tutorial, and this time we're going to be looking at window functions. There is already some videos on my channel regarding window functions, but I've had a lot of feedback from you guys to ask if I can do a video where you can follow along, and this is that video. So we're going to go through some examples. I'm going to put the code for you in the description. You'll be able to create the objects and follow along with the video as well. And let's dive right into it. Let's head over to SQL Server Management Studio and start working through some examples. Great, I'm in SQL Server now, SQL Server Management Studio, and I've got a script here that's just simply going to create a sales details table. Again, this is just a hypothetical table to allow us to work through these examples that we want to cover in this video. So first of all, we're just going to check if this table exists. If it does, we're going to drop it, and then we're going to create this table. It's going to consist of a few different columns with a few different data types. We've got a sales details ID, which is a primary key. It's set as identity, so it's going to be automatically generated for us. We've got the sales ID, so this table is effectively breaking down the detail of a sales line into the individual products. We've got the sales date. Typically that would belong to the sales table, but it's in this for this example. We've got the product ID, the product that it relates to. The price of the product, again, would typically be stored in that table. The quantity ordered. And then last of all, we've got a computed column down here. So to save me having to manually work out the price times quantity, that's automatically going to be generated for me as soon as I insert some values into price and quantity, and it's just a simple multiplication of the two. I'm going to insert some values into this table, so a small number of sales details rows into this table. And again, if you want to follow along, the code will be in the description for you to do so. I execute this query and we've added 17 rows to that table. We'll move on to a new query window, and I'm just going to write out a select all as our starting point for these examples. So we're just going to select all from our sales details table, just to demonstrate that we have got some data in here. And now we're going to cover some hypothetical scenarios. So we're going to first start off by looking at group by. So let's say we want to calculate for each individual sale the total. So a straightforward query that we'd start off with is we're going to group by sales ID, which is the representative of each individual sale. You can see here in the results grid we have numerous sales details ID per sales ID. So as I mentioned, this is the detail rows that belong to each sale. And what we want to do is sum the line total. So we type out sum line total, and I'm just going to give that a name as it's an expression, and that's going to be sales total. And then we're going to add in group by, and it's going to be grouped by our sales ID. Let's have a look at what that looks like. So we have a small amount of individual sales that we're working with, because this is just an example. Typically we'd have a wider range of data. So we've got 6 individual sales IDs, and we can see we've got the sales totals. Sales total. Now the problem with group by is that we've actually lost the detail here. Let's say I wanted to return other columns, such as the price or the product ID. Now I can't add them to this group by query because I actually want to calculate the total by sales ID. So the problem is, if I show you an example with product ID, for example, if I say I want to return product ID and I try and execute this query, I will get an error to say that you can't return product ID because it's not contained within an aggregate function or the group by clause. And what that means is I have to wrap this within an aggregate function, or I have to group by it. So when we're grouping data, remember, after we've applied the group by clause, so in this query, first we're going to select all the data from our sales details table. It's then going to group by sales ID. Once we apply grouping, we can only return one row per group. Now, even if product ID only had one distinct value, SQL Server doesn't know that. You have to tell it. So if it was only one value, if each line had exactly the same product ID, we could apply something like a max or a min, an artificial aggregate function. But in this case, we have numerous product IDs. So if I add product ID to the group by clause, and we'll have a look at the results of those. The problem is now I haven't got the 6 groups I wanted. I'm now grouping by sales ID and product ID. Now the way around this, typically, historically, sort of pre-SQL Server 2005, was what we'd have to do is compute this total and join it back to the original table, which we'll go through an example of doing. So we're going to put this within a common table expression. So if I say with CTE, and I just like to indent data within subqueries or derived tables just for better readability. And then what I want to do is return the detailed rows from my sales details table. So what I have is sales details ID, sales ID, and I will need to alias that, which I'll do shortly. Sales date, product ID, price, quantity, line total. And in this case, we also want to return this column that we've computed within the CTE. We want to return our sales total. So what we're going to do is look back to our sales details table, and we'll just give that an alias as A for simplicity. And then we're going to join that to our CTE, and we're going to be joining it on sales ID. That's the only column available within the CTE that we can join on. So effectively here we have 6 rows, whereas in the detail table we have 17 rows. So it's going to return multiple versions of our CTE per sales ID. And I will need to alias this as it exists in both. I've executed that query now, and now we have the detail rows, so the underlying detail from the table, the underlying rows, and then we also have our sales total. And we can see for the first 3 rows they all have the same sales ID of sales ID 1, and we can see they have exactly the same sales total. And this is where window functions really provide an advantage over group by, is that they don't remove the detail. We're still able to see that detail within the query, and we'll go through that now. Now the downside of this is that we're actually looking at this table twice. If we think about that, that means SQL Server is going off twice to fetch the data from this table. Let's have a look at how we can perform the same operation with window functions, and perhaps even a bit more. So I'm just going to copy this select statement to save me writing it out again within the video. So at the moment we don't have sales total, and I'll just remove that alias. We are using again our select statement as our starting point. So we know from the previous example what we want to compute is the total per sales ID. Now window functions are available in select or order by. So it's important to note they can be used in conjunction with group by because they're processed after. So we could apply a window function to a group. So let's type out our query, which is going to be sum line total. Now within the window function, we use an over clause to define our set of rows that we want to operate on. So we have over and we open brackets, and in this case we're going to be defining our partitions as sales ID. So what we're effectively saying is sum the line total for each matching sales ID. So we have the divide each sales ID into little partitions, and once you get that, I want you to compute the line total per partition. So we add partition by sales ID, and we'll alias that as sales total as we did before. So we can see there within that query we're partitioning by our sales ID and we want to compute the line total. Let's take a look at adding that to the results. So we've now got our sales total in our results grid, and we've been able to retain the detailed rows. And we can take this a step further, so all aggregate functions are available within window functions, and we can define different partitions. So let's do an example of a different aggregate function. Let's use count. So let's say we want to count the amount of lines per sale. So we're going to count sales details ID, and we're going to use exactly the same partition. Notice that we have to write out each individual line, so we couldn't say sum and count by this partition. We have to write it. Each individual window function will only return one value, so we have to have it on we have to code it out on separate lines. So we'll do count sales details ID, partition by sales ID, and we'll call that sales count. Let's have a look at those results. And we can see for sales ID 1, we've got the sales count of 3. So again, we've got the detail and we've got the aggregation. And if we look at sales ID 2, there are 2 rows, we've got the count, we've got the sales total. Now what if we wanted to compute the grand total? So if we wanted to say, give me the total of everything in this table. So typically, moving back to our group by example, we would have to do numerous group bys. So we'd have to have one query that showed us the total of the table, one query that showed us the total per sales ID, and then we'd have to join those back together. So we'd have, effectively, we'd be hitting that table 3 times. Let's demonstrate how we can do it with window functions. So again, we want to sum line total, and as we're using a window function, the over clause must be present, but we don't want to partition our data. We want to use every row within this table. So we just simply open and close brackets, and we'll call that sales grand total, just to differentiate between the sales total. Let's take a look at those results and how they look. So we now have on each line a sales total, a sales count, and a grand total, and that will be the same value for every single row in this table. Now typically when we're computing a grand total, we probably wouldn't want the details, but this is just a way we can get it. So if you think about it, if you have 1,000 rows in a table, you will have that grand total repeated 1,000 times. But if that's what you need, that's fine. We can also define different partitions, so we don't have to consistently use the same partition. So we've used sales ID, and in our grand total we haven't used any partition at all. By leaving that blank, we're saying we want to use all data. Let's have a look at a daily total, which is why I had to add sales date to this example. So if again we go sum line total over, and this partition is going to now be by sales date, and we'll call this daily total. Let's add that to the query and have a look at the results. So again, for sales ID 1, we've still got the same daily total as sales total, and we would expect that because typically the one sale will exist on one day. But where that gets a bit different is where we have multiple sales on multiple days. So if we look at sales ID 2 and 3, if we look at sales ID 2, just to narrow it down, we have a sales total of £17.38, but the daily total is £83.88, and that's because 2 sales happened on the same date. And we have the same further down with sales 5 and 6. We can see sales ID 5 has only got one line. The sales total was 71.96, which, as it's only got one line, matches the line total as well. But the daily total is £172.86 because sales ID 6 also happened on that day. And we can partition by multiple columns as well. So let's add in a sum line total over partition by. So let's partition by sales date and product ID. And we call that daily product sales. If we execute that, if we have a look at daily product sales, we can see here it gets interesting for sales. I'll just order that by sales ID just to show the results in a more readable format. So now what we're doing with daily product sales, it's partitioning by the date and the product ID. So we can see at this particular row here, our sales total is £17.38. But for the first line, which refers to product ID 2, our daily prod sales is £11.96. And that's because, as well as making this sale on the same date for this product, we also made another sale, which is sales ID 3. So that's a demonstration of how we can partition by multiple columns. I would just hide some other columns just to make that a bit clearer. So if we, sales detail ID doesn't really mean much to us at this stage. We'll take out price and quantity. Hopefully that's a bit clearer on screen now. We can see the sales ID 2 for product ID 2 has a line total of 598, but the daily product sales total of 1196, and that is because within that partition it also includes this row here. So the sale happened on the same date for the same product. So you really need to understand, when partitioning by multiple columns, what that partition is actually showing you. The other benefit of using window functions, I'm just going to uncomment all of the rows we're missing, and in fact I will comment out the window functions for now. Is the other benefit is that we can use these values. We can use window functions to actually compute a percentage of total. So we can actually perform a window function over different partitions and use that to compute a value, which is what I'm going to show now. So I'm going to start off with the calculation of line total partitioned by sales ID, and I want to compute what that is as a percentage of the grand total. So I'm going to compute that, and I'm going to divide that by the grand total, which, as we didn't use a partition by. And if I go ahead and just show you what that looks like at the moment, because we'll need to apply some manipulation to the data, it's just a decimal. So if I start with a quick way to convert your results to percentages is multiply it by 100.00, and the reason that's a decimal is because of data type precedence. So it will know you want to return those results as a decimal. If I just put in 100 and executed it, because the values are already a decimal, it will work okay, and we'll alias that as percent. But if you're working with ints, with integer values, and you want to compute a percentage as a decimal, you can just simply multiply one of the values by 100.00, and because of data type precedence, it will convert the results to a decimal for you, and we'll alias this as percent total. So if we have a look at that now, we can see that sales ID 1 represents 19.6 rounded up of the grand total. Sales ID 2, very small amount, and sales ID 4 looks to be our largest at 23.5%. I will add all of these window functions, well, this whole query, into the description. So if you've been following along and have lost track, you'll be able to view this within the description as well. I really hope you have enjoyed that video and have enjoyed being able to follow along with window functions. If you have, subscribe to the channel if you haven't already, and hit that notification button to be made aware of when new videos are uploaded. Check out my other videos on the channel. There is lots of great content on SQL programming, SQL querying, business intelligence. Thank you. Thanks a lot for watching.